So I'm Neil McRae. I look after BT's technology strategy. I have the kind of bizarre title of Chief Architect, which is, I still don't fully appreciate why or what that's for. But anyway, I thought I'd start with a picture of the SR-71. Who's heard of the SR-71? The fastest plane where you can breathe air on it. And what's interesting about the SR-71, in relation to the talk, and I'm a bit of a space nut, as many of you may know, you should definitely try and win that Apollo rocket, is the SR-71 was all about, you build an aircraft, and actually it was built in secret, even secret from the US government, and actually it was made of titanium. The US didn't have any titanium, so most of the titanium in the SR-71 stolen from Russia, which I thought was incredible, given that it was the 60s and the Cold War was on. But it wasn't just about building a plane, it was about building a new way to build. And that's kind of the thinking I tried to give to people who are building networks. I think in our industry, we kind of, we have too many people saying we've tried that, or we did it that way, or we tried it before. And actually, often, if you try again, or just change it ever so slightly, things can be different. There's a book called Sled Driver, I think it's called, by one of the pilots of this. I highly recommend reading it. It's a phenomenal book. So back to networks. This clicker isn't working. Thank you. Next slide, please. So I thought I'd just start a little bit with the R&D that we do at BT that I'm kind of the lead sponsor for in terms of the output. We invest a huge amount of money in research and development, and if you go into the next slide, that's actually pinned by, we pin that research down to what we perceive as key areas of improvement in the network. And this is just the ones I could remember whilst creating the slide, but if I think about, we talked about telemetry, and we're using that for autonomous healing in the network. Actually, this year the voice network, believe it or not, hit 5 nines for the first time in a while, and it's a technology that's almost as old as the SR-71, but it's a platform that's got huge, pretty much every traffic light depends on the voice network. Every missile scare, yeah, nuclear power station depends on the voice network. So it's important that it's reliable, and there's things that you can learn from how you run and operate the voice network. And I look at the voice network as almost like a cloud. It has a whole bunch of processing units and a control plane, and it's distributed. And when you have a problem with it, few people know about it, and it'd be great if we could get that capability more into the network, and we kind of analyze that. So these are some of the partnerships. In fact, I was at Cambridge University yesterday. Anyone heard of graphene? Yeah, graphene in telecoms. So graphene in telecoms is very interesting because you can use it as I guess the word's like an accelerant or an agitator on silicon, which means all of a sudden the optics that we can only drive at a certain speed suddenly can go faster. If I give you an understanding, in our network, we have some segments on our optical core where we've used 96 wavelengths, and we have to use another fiber. Getting another 20 or 30 can be really valuable. We're doing a lot of 5G research with Bristol. In fact, we're building a little 5G network in Bristol and here in London with King's. And I think the point is experimentation and research is something our industry needs to do a lot more of. And I'm not talking about the vendors, I'm talking about us, in partnership with universities, in partnership with vendors and open source and other organizations. Our network, just very quickly, we have just under 2,000 Ethernet nodes. We have superfast fiber access to, I think, 92% of the country. Our core network's in 106 sites. We have MPLS to 1,800 sites. We have a high-capacity optical platform that's on 106 sites and is extended in London for the metro connectivity. We typically operate a 3-exit network. which in some cases isn't always 3-exit because of the fiber topology. There are some parts of the world where doing a third route requires you to make a mountain go away, and that's expensive. And what we've been doing a lot more of is, and I have to shout out to the Comcast guys, because I think what they've had to cope with in terms of bandwidth growth over the last few years is pretty unbelievable. And some of the things they didn't do that I'm thinking we should be doing about multi-layer modeling and models in general are really important. We also carry a huge majority of the mobile traffic in the UK as well, and obviously we own EE. This is kind of how we think about our networks. Very simple. It's very simple, but it allows us to talk about it. And actually, language is an important thing. You hear quite a lot of language today where people mean something slightly different. But it starts off in access, so we have OpenReach and we have radio access. Through wholesale, we have ADSL. That goes into MSE, which is a Nokia 7750. And then we have our P network, which is 212 routers in 106 locations. With 100 gig, in fact, there's one side that's got a 400 gig test in it right now. And we run, bog standard MPLS or IPVPNs for some different services. So the mobile network is in a VPN, for example. We run Ethernet across it. Many of you are customers of this, and we appreciate your business and your challenges, because our goal, my personal goal, is to make networking better and make the world achieve what it wants to do through networking. That's why I work at BT. You can see some of the paths. So, and I've spoke about this before. If you look at one of my previous presentations, I showed a population and traffic, a population coverage of the UK. Everyone says, why is all the traffic focused on the southeast? It's where all the people are, of course. And it really is that simple. What we're starting to look at is does IoT or machine-to-machine technology drive that differently? We also have a number of regional hubs that we show there, where we see some element of regional traffic, but it's in the margins. I thought I'd talk a little bit about, there's often a lot of talk about what we should be building in the network. And actually, clearly where we go with the network, and I've worked for some companies, clearly where we go with the network has to be profitable for us as an industry, not just for BT. And I've worked for many companies, as I'm sure some of my colleagues have, where we spent a lot of money building network and never got the return. And what happens very quickly is it's a race to the bottom, and you go out of business or you're acquired. So I worked for Cable and Wireless. We couldn't invest. We couldn't make enough money from the network, and they were acquired by Vodafone because there was just nowhere to go. But what this shows is the kind of growth that we see year on year. So the top graph is how we've seen traffic. Ignore the bottom bit. The bottom bit's just a year. Ignore the date on it. It should just be April to April. We're trying to show a year, and then we're trying to show the traffic, peak time fiber usage per user. So if you go back to 11/12, which is the bottom line, you can see what the difference. So that was the UK Olympics, which doesn't feel that long ago. And you can see that the traffic growth year after year is pretty significant. What we tend to see is from kind of August till about, it says Easter here, but it's probably more like March, early March, we see a lot of growth, and then it's kind of quiet until the August again. And actually for us, that's very helpful because our financial year starts in April, so we can build a load of capacity in April and get ready for the kind of surge that starts usually when the schools go back after the summer holidays. You can also see in fiber and copper, and yeah, there'll be some smart guys saying, is that fiber really fiber, is it copper? And it's effectively our NGA platform. So what we see is a huge, we still see a massive amount of growth in copper usage. That's ADSL. And the interesting thing about that is, the world and these armies out there are saying everyone should get fiber, but we have many customers who could have fibre today, or fibre from the cab, that choose not to, and it's a significant number. Perhaps down to economics, perhaps down because what they've got works for what they need today. I'll show you an interesting stat on my home network later on. CDNs, so we've been working with the CDNs since 2011 when I joined BT. We had a bit of a mad policy, which was we're going to try and make money out of the CDNs. I said, no, I don't think that's a good idea. Why don't we work with them and save a load of money? As you can see, most of our traffic is CDN traffic. Peering, we all run around and have lots of peering conferences. It's becoming less of a thing for me to worry about, frankly. I can kind of see that fading away over time as we get very much, as the network itself evolves away from this kind of mode of working that we have today. And places like, even the links where I was on the board there for 15 years. The value of that in our network it's important, but it's not what we're constantly thinking about. And peering interconnect is not what we're constantly thinking about anymore. It's much more about bringing quality connectivity to the customer. We also use multicast to deliver TV. I think I've talked about that in another presentation. I thought I'd cover, the Sky guys did a great presentation last time. This is Manchester City versus Liverpool. I think if you're a Liverpool fan, it's probably a great day to smile being in Manchester because they won, but it was the biggest event on our network. So just in broadband, this doesn't include anything else, we were carrying 10.3 terabits a second. That was served from a few CDNs, our own CDN, and the guys at Akamai who do a fantastic job. And actually, that wasn't a high number of customers. So concurrence is the thing that really keeps me awake at night. If someone came out with an app, and I kind of look at I don't know if anyone's played the game Fortnite, where you get huge concurrence. Like there's an event a few days ago where there was just massive concurrence of people playing that game. And luckily it doesn't use a huge amount of bandwidth, but high concurrence, high bandwidth services. I've just lost the screen. Oh, it's back. High concurrence, high bandwidth services are very scary. Fortunately, not everybody likes football, and otherwise, it gets hard. The last thing that was big like this, that was high concurrence and high usage, really huge thing, was the guy who jumped out the Red Bull balloon. Luckily, YouTube only had standard definition then. Otherwise, that would have been a very bad day. This is an interesting graph. I'll let you think about it for a minute. What this graph tells us is, and we have a more detailed version of it. Unfortunately, I was kind of said I can use it, but leave my pass at the gate on the way out. But basically, what this graph tells us is that we see more users, even in the bottom end of the network, kind of up to 24 megabits per second, really starting to hit the line speed much more often than they did only a year ago. And what this is telling us is that we're starting to see the ADSL type technology become, a limiting factor to consumption of the internet. And actually that's taken quite a long time if you think about it. If you think about dial-up, it was almost game over from when we started dialing up. We could never get a fast enough modem. But what's interesting about it is it's not really driving a change, which I kind of struggle with, which is, okay, you've got 20 meg and you're hitting that 20 meg peak, you're hitting that 20 meg limit quite a lot, and you can have fiber. Why aren't you buying it? When people talk about investing in networks and building FTTP, and you look at that, it starts to be really challenging, basically. But you can see that the curve has swung from October 2014 to September 2017. So this is my line at home, and I've got more bandwidth than probably most people, including some of the companies at home. And I never. This is from March to April, the last month. I have 40 gigabits per second to my house. And 45 megs my peak for the last month. So, you know, when you look at it like that, and I'm a heavy user, I mean, I've got all sorts of devices. I've got an Xbox that seems to update every time I blink at it. Actually, last week, my TV decided it wanted to download an update. And most of these peaks are some sort of patch or some sort of update. And you know, and in here I had a huge pinball tournament at my house, and I gave everyone. I wanted to really hammer the line. I gave everyone, you know, the best access I could give them, and it's not even noticeable on here, which is kind of peculiar. Anyway, so the goal is, you know, so you kind of think maybe some of this to do with pricing. So clearly, we all in this industry, for the most part, sell products where if the customer consumes more, it doesn't necessarily translate to revenue. So we're really focused, and actually most of the work that we're focused on is either getting more bandwidth for the same price or getting more bandwidth for less price. Since 2012, we've taken 70% of the cost of our network out. And that's predominantly on our architecture, which was quite complex and actually was very focused on voice to move into an internet-focused architecture. And we're about to deploy the fourth generation we are deploying the fourth generation of routing engine for 21C. We've got 200 gig waves in production. We're about to do 400 gig waves into production. We've got an optimized metro core in London. And we run a WDM platform that has one optical plane, which has made life a lot easier for us and some of you guys that buy from it. And it's all really been focused on unit cost pounds per meg, and everything that we've, you know, probably 60% of the work that we do in network architecture is focused on that. This is our next generation routing platform. It's a Nokia SRS. It's a petabit scale router. And we've started putting them into the network. And so far, so good. We currently have the main workhorse of 21CN is 7950 XRS. You can see that router there is probably the busiest. It might be, although Akamai or Netflix might beat me on this, but today it will hit 16 terabits a second. And it's in central London. It's a pretty busy box, and we have a sign on it saying "touch this and die," or we will have. So it's you know, trying to, you know, it goes back to my earlier point, which is we've built networks, you know, bigger box, bigger box, bigger box. Actually, the bigger boxes are becoming a problem. Let me do this slide first. The bigger boxes are becoming a problem because not only do you need bigger boxes, but you need huge infrastructure. We managed to close a bunch of main roads whilst we installed new chillers into a glorious place called Baynard House. Nigel's probably having a heart attack right now just thinking about it. Where, you know, the cooling requirements and the power requirements for these devices is just insane. I mean, watt per gigabit and kilowatt per rack, etc. You know, they're all kind of going in the right direction, but it's basically more. And actually, you know, and then you've got to think about. I have 5,000 exchanges with roughly at least 5,000 UPSs, if not 5,000 battery sets, probably 10,000 generators. They all need to be maintained. They all have to be upgraded, and it's a big effort for us. And it's expensive, and again, so one of the other things that's a big kind of journey for us is over the next probably 10 years is exchange closure, and we've done 3 or 4 of them to kind of test it over the last few years, and it's or closure or moving them, and you know, we know what the opportunity is at. We did a model actually working with Bell Labs. If you were to build BT today, how many locations would you be in? You could probably build it on 800 locations as opposed to the the 5,500 that we're in today. Let's talk a bit about 5G. Actually, there was a slide I missed. We're also looking at, what's great about it is the optical vendors have finally realized that building these big boxes is madness, and building kind of slim, very focused devices used for data center interconnect. You can see at the bottom, that's a 400 gig transponder that we've been testing. Seems to work. But getting more and more, getting these devices smaller unfortunately increases the heat. So it's kind of a bit of a trade-off, but we're working with a bunch of suppliers in that space, and also in Whitebox, which I'll come on to in a minute. So 5G, we just acquired some spectrum. We're building out right now in London, and also at the same time rolling out much more into 4G with more carrier aggregation. In London, you can, if you've got the right phone, and in the centre of London, the kind of baseball cap area, you can get 800 megabits per second on your phone. And again, in London, we're already busy, and we have to cope with that. It puts a lot more effort onto the core. And then we're doing massive MIMO testing, which is really important for higher frequency spectrum, because we need to bend it around buildings. Our core network for 5G, basically, we don't talk about fixed or mobile anymore, we talk about the core network. And I think increasingly that's going to be important, and it's why I kind of flagged the thing about, don't assume that you've got diversity in wireless and non-wireless, because you probably don't. Talk a little bit about network cloud. I'll skip this slide and this one, jump to this one. So, Rob Shakir, who used to work for us, did a great presentation on segment routing, something that we're pushing very aggressively, because we need to scale we need to scale to the dense, imagine every traffic light, instead of being connected to the traditional transmission network, is now connected to the IP network. You think about how many devices you need to do, how much control plane, how much optimization you need. We believe that probably just optimization is probably worth 20% of our investment if we optimized it perfectly. And using segment routing with MPLS SR over UDP into the data center, we think will give us a lot of control over the traffic with path computational devices that will dynamically create paths between the network. Anyone who's rolling out MPLS TE, please stop and do this, because we've done MPLS TE and it's rubbish. Telemetry, so this is a problem that kind of dated back to the Olympics, and we actually came up with a solution. We just didn't have time about it. Well, the thing that kept me awake during the Olympics was 10 seconds of Usain Bolt in the 100 meters, because we wouldn't even, if something had gone bad, we wouldn't know about it for 5 minutes later, whilst SNMP had its party. So that's where the telemetry idea came from, and it came from, if you think about this, and this is a crazy thing, NASA were doing this in the 60s. They had a whole lot of stuff come into a mainframe, and the mainframe decided what was important and flagged it to the people. Why can't we do that with networks today? So we've been working on telemetry now for almost 3 years. It's starting to come into code. If you're not looking at this, I really encourage you to look at it. Because I think this, everyone talks about NFVI, SDN, a whole bunch of other nonsense. I believe that this is the most important thing that we can do in networks today. And I think it will have the biggest change. And it's great if I do it only and we get a benefit from that, but I'd quite like the industry to tag along. This is kind of a high level. So we have some machine learning on our telemetry platform where we'll see something happen. We'll solve it. The machine learning will see what we did to solve it, and it will do it again. And we have this running in our operations center up in our Astral Park. It's very early days. There's a lot more to do, and we're not, machine learning and AI is there's a lot of ranting and raving about it, but there's probably really only 2 companies that know what they're doing in this space. We're using all the usual open source tools that have been mentioned before, although we've decided to write our own deployment software, because we didn't rate Salt or Ansible or any of the other ones that are out there, because of some of the things that we need to talk to. Because I don't want this just to apply to the future. I need it to apply to my legacy, because probably the voice network's going to be here for another 5, maybe 6, maybe 7, maybe 8 years. Whitebox switching, so again we have this almost at deployment as an aggregation layer. We're working with Bearfruit on this as well, because I think Whitebox switching just takes my reliance on vendors away and gives it to Broadcom or Intel or something like that, so I want to have more flexibility in that. But this stuff just works now. A huge effort by the software guys to drive the right quality. It's incredible the quality that's moved on this, and we're also working on this on optical platforms, including head-end technology for FTTP rollout. And that is my talk. Thank you very much.
Thank you very much, Neil. Do we have questions? I mean, Neil has whistle-stopped so many fascinating topics. Do we have any questions from the floor? There's one over here in the middle. Trev.
It's very interesting, Neil, thanks. You've thrown so much at us there, it's difficult to choose a question out of that one. But one thing that caught my attention was the 800 megabits per second speed from a phone, right?
Yeah.
What applications do people envisage that kind of speeds from phone, especially when you think that you were only doing 45 megs at home peak?
Snapchat, of course. Have you not seen it in the city? They're like stormtroopers. There's hundreds of them, and they're all Snapchatting at the same time. You know, it's a really good question. And as I prepare the roadmap and plan a record and all the capex we have to spend, I often ask myself, 800 megs, what are we going to do with that? You know, but I think I'm kind of a believer that if we had that same mindset in the early 90s, you know, we wouldn't have an internet. You know, we built a lot of this not knowing what it would lead to. So my hope is that there is a use case for it. Now, it's not that we build, you know, there's an element of build it and they will come, but actually it's also an element of demand, and we will, so yeah, you can get 800 meg on your phone. I'll probably move around a little bit as we get more customers connected with faster phones. I mean, the big challenge in phones is battery life, of course, so that does provide a limitation. But, you know, perhaps we can use some of this technology in hard-to-reach places. And I'm not just talking about rural. There's many hard-to-reach places in urban locations as well.
We might have time for just one more question. Go on in the middle.
Hi, Neil.
Hey,
you mentioned the stats where you've got people who are still on ADSL, even though they could get VDSL connections.
Yep. And fiber, some can get FTTP.
Okay, so do you have, ignoring the FTTP for a second, because that could be availability, cost, etc., do you have any stats on where, because of line distance length, if they were to upgrade, it would either be about the same or worse? Is there an element of that? Because obviously the technology is more sensitive.
I mean, so, you know, assuming the copper is of the quality it should be, and I know in places that it isn't, and we try to fix that as quickly and as best as we can, but assuming that's the case, there's very few places, it's tiny the amount of places that wouldn't see a benefit. You know,
okay, so it's just customers not taking it up.
Yeah, and you look at, you know, I mean, have a look at the two other guys that play in this space, Sky and TalkTalk, where, you know, a big chunk of their customers are still on their DSL platforms as well. There is a tranche of customers that don't live the world we live. You know, that Netflix, if it plays at, you know, a slightly blurry rate, actually is okay for them. Yeah. Versus, you know, many of us live in a fortunate world, and some people don't. And that's why reducing the cost constantly is really important. But also, I think we need to think about the right way of bringing the cost down so that we enable it for more people and we're more inclusive, but at the same time not doing that before we can actually deliver it. And I think there's some actions that we've taken in the past, mostly through regulation, where, oh, we'll make this really cheap in market A or market 2 or market whatever it is. All you've done is make it harder for me to fix it. And it's, you know, I can't stress how important it is that if you're not able to generate cash to invest, you run out of road in this business incredibly quickly. And you know, that is the big network challenge over the next 10 years. And then getting the most out of it, I think we're a lazy lazy industry that doesn't optimize in the same way. You look at how BMW make cars, and I've studied it. They have a bunch of things watching how cars are made, and every 2 or 3 weeks they'll say, okay, rather than putting the tire on like this, put it on like that. We do none of that stuff predominantly. There's some places do it, like some of the cloud guys, but in the network space, it's not as, we don't invest in that as much as we should do.
And on that note, I think we'll have to leave it there. Thank you very much, Neil.